All right, so let's continue with built-in data types. So a data type is a set of values and a set of operations on those values. So various different data types: string, int, float, and bool or boolean. Set of values. A string is sequence of characters like hello world. CS isn't fun. Well, it is fun. Operations can only be plus. So again, this I have covered in the Princeton Intro CS course. This example, so you can have a look there too if you want extra explanation. So int are integers, whole numbers, any positive or negative whole number without a decimal. These operations you can perform on them. Float is a floating point numbers, anything with a decimal, plus or minus. Again, just like Princeton notes, it doesn't show negative values, which I think is still useful to show. And the operations, normal operations for numerical values. And bool, these are truth values, logical values, either true or false. And you can use and or not with them. So these are Python's built-in data types. So pop quiz on data types. What is a data type? Well, as mentioned, it is a set of values and a set of operations on those values. And you get three types of data types. So that is the string, int, and float. So again, there's the answer to that page over there. So basic definitions. A variable is a name that refers to a data type of value, identifies Python code a representation of a name. A literal is a programming language representation of a data type value. Assignment statement using the equal operator associates a data type value with a variable. So a single equal sign is used for association, not for assigning or for not for equating two values, but for association. So an expression is a combination of literals, variables, and operators that Python evaluates to produce a value. So there's a very simple example, again, in the Princeton notes. A equals 1, 2, 3, 4, B is 99, C equals A plus B. So these are variables A, B, and C. Your literals are the numbers 1, 2, 3, 4, and 99. Assignment statements, these are the assignment statement with an equal sign. And then your expression is C equals A plus B. The meaning of equals in a program is not the same as a mathematical operation, as I tried to mention. It is assignment. We're assigning one value to another, or a value to a variable. Objects. An object in a in computer memory, an object is in computer memory a representation of a value from a particular data type. Identity. So there's three properties. Identity is uniquely identifies an object's memory address. Type, the set of values it might represent, and the set of operations that can be performed on it. Value, the data type of value that it represents. We have object reference. An object reference is nothing more than a concrete representation of the object's identity in terms of the memory address. So again, this, we don't have to know in depth how this works. And if you want to use Python, it is useful to know how it works behind the scenes. And as you get more into understanding of like classes, this becomes more relevant. But for now, it's just for reference. So here's an example from the Princeton notes, from the Princeton course in terms of showing the variable name, the object reference, and then the object as well that you are. So those are objects. Expressions, again, this is from Princeton notes, operands and expressions 4 times, brackets, x minus 3. The operator is the star, which refers to multiplication. And this is a typical expression that you might use. So we have operators, specify data type, operations on one or more operand. Operand can be an expression. Binary operators take 2 expressions. Precedence, multiplication, division before addition and subtraction, like BODMAS. Left associativity, ABC, same as A minus B, brackets minus C, all operators except exponentiation. Right associativity, A to the power of B to the power of C, same as A to the power of brackets B to the power of C. Parenthesis overrides precedence rules. So follows the BODMAS methodology. Again, these are technical terms describing this, but Python allows you to, as you learn mathematical operations, you type it out. So this over here should be quite straightforward to do math operations. These are just assigning technical terms to it. Exercise definitions. So full and missing labels: A equals 0, C equals A plus 1, C equals C plus B, C equals 2 times C plus 4, C equals 2 plus D. So this is obviously an assignment. This is a literal pointing to 1. This is a variable C. This is an expression 2 times C plus D. This is operator. Let's see if I'm correct. Assignment because of the equal sign, literal operand, a variable operand, expression, and operator. Yeah, so I got those right. So object trace program behavior is typically understood using traces. So again, this is quite technical in terms of the in-depth how this works behind the scenes. You don't actually have to know this in terms of using Python. It's theory and it's the technical aspects of how the program works behind the scenes. But this was also cover this in the Princeton intro course, so you can. So again, this is just for reference, and we're going to go through it in any case. So program behavior is typically understood using traces. Informal trace table showing values after each line of program. So it's sometimes useful to use this to understand how a program follows certain operations line by line. It is useful to understand. So object trace shows variables, object references, and objects for each of the line program, for each line of the program. Object trace examples shown below. Formal trace, so we have choose 3 assignments, T equals A equals B equals T. And it shows how, for example, A is initially 1, 2, 3, 4, B is 9 to 9. So this is initially what the variables are assigned to. The next line of code is T equals A. Well, A is still 1, 2, 3, 4, B is still 9 to 9, T was nothing initially. And now T is assigned to 1, 2, 3, 4 because of this line, T equals A. Next line of code, A equals B. So A still says the same. B is 9 to 9. Sorry. A becomes not 9 to 9. I was looking at the wrong line there. A becomes 9 to 9 because 9 to 9 is now assigned to A. So 9 to 9, B is still 9 to 9. And T is still 1, 2, 3, 4. Nothing's changed. The last line of code is this one. B is still 9 to 9. Sorry, A is 9 to 9. B now takes on the value of 1, 2, 3, 4. And T says 1, 2, 3, 4. So this is informal trace, how it works. It is useful to understand how this works behind the scenes. This is how the code would work in terms of writing it out. Very formal approach to understanding this. And you have object level trace as well. So this goes into even more complexity in terms of the values, how objects are referenced as values are assigned to different variables. So basic conversions. So we have basic conversions, string to int, for example, int 1 to 3 and int sys.argv. We can convert values from, we can convert strings or input values to integers, which allows you to do numeric operations. So, as importantly, when you read in or sys.argv1 is by default a string. So if you want to use it numerically to do numeric operations, you need to convert it to integer or float. You can also into string as well if you have a variable a equals 1 to 3. And again, if anything with quotes is a string, you cannot add a plus b. You have to first convert it as it's been done here, and then you can write out the output using right line. And then 1 to 3 become 9 equals 2 to 2. This is from, again, this is a bird's eye view of a Python program. We have input strings, a black box, does something, and output string. So text. The data type for computing with strings will use str. This is what's used in Python, and string. So the data type string, str, the values is a sequence of characters. They can be letters, numbers, or characters themselves. So literals can be hello, one, or star, or text itself. Important note, character interpretation depends on context. So operations, you can concatenate, you can add two words, two letters together, which you'll see that. Operation is a plus symbol, just like we've seen in this example here. This is concatenating strings using a plus symbol, adding the strings together. You have certain escape sequences as well you can use for tab, for new line, and other things as well. So for example, you have an expression here, hi plus Bob is hi Bob, 1 plus 2 plus 1 is 1, 2, 1. And this is all text, is not numerical operations happening, right? Because of the quotes. And the rest as well. And also have example plus signs, so 1, 2, 3, 4, plus character, plus 99. These are operators, and this is the character that's been added. And here's also white spaces as well, so to notice to give spaces. So we can do a quick example just to show you how it works. I can maybe do this in here, because these are very simple examples, like for example, 1, 2, 3, 4, plus, and space plus, plus 99. So there you get 1, 2, 3, 4 plus 99. If I didn't have these spaces here, for example, it would be put together. And again, this is all these are string, these are characters, these are not numerical values because of the quotes. And another example, I can say hi, comma, space, as in plus, Bob. Hi, Bob. So hopefully you understand how that works. Example of computing with strings, subdivisions of a ruler. So this example, again, is from the Princeton course. We can write this out as well. Although we actually have it from the course. So let me get the file itself. We can try it out. So let's now add a new file called ruler.py. Over here. Let's expand this a little bit so we can see what's happening. So again, this is this is a link for the file. All this again is from the Princeton course. So if you can go to this link if you want. If you want the file, so what does this do? So write to standard output the relative lengths of the subdivisions of a ruler. The nth line of the output is the relative length of the marks on a ruler, subdivided in intervals, 1/2 to the power of n of an inch. So we can maybe use millimeters or centimeters. For example, the fourth line of the output gives the relative lengths of the marks that indicate intervals of 1/16 of an inch or millimeter on a ruler. So I think this is, maybe a trivial task, for example, but it's just showing you how the code works, or how to add and concatenate strings. So we start with ruler, and then for each time we are incrementing that, adding a value of 2 and 3 and 4 and etc. just by concatenating and then writing out the standard output. So if you run this file, so let me just exit my interactive terminal and I say Python ruler, I get the same output. This is showing the marks for a ruler. All right, so this again over here. So it explains each step, what's happening, creating the 1 to 1, and then 1 to 1 121, 3, 121, and the fourth one as well. So what does the following program do? What does the following program print to the terminal? So this is a little bit different. So let's maybe modify this code and see what it does. Let's drag my code over here so I can just see that over there. So let's replace one with X and replace this one with star, and this one with hash, and this one with star as well. Save the file. We don't need this extension. Right again, Python ruler, and we get star, X's and stars and the hashes. So we just replace the symbols with numbers. What does the following program do? Well, it gives a modified realm that it shows. So I just want to see if everything's the same. It looks like everything's the same. I think what is different is they're only doing really full. So let's see what we get. Run it again. Yeah, so that's exactly what they're getting at the bottom. So only printing the last one. All right, integers. So, okay, thankfully they do show negative numbers here because the Princeton course notes didn't show negative numbers, only positive ones. So integers are any number, any integer, negative or positive. So integers, int data type represents integers or natural numbers, values. Again, we only work with Python 3 here. So literals, large numbers, again, these notes are from Princeton course, so they didn't add negative numbers, unfortunately. Operations, addition, subtraction, standard math operators, and these are operators you can use. Using the double slash symbol for divide, this floors the divide symbol. What does that mean? Well, let's show you. I'm going to, where's my, the one I want. Let's go back to this and go to Python. So if we say 9 divided by 3, we get 3.0, which is actually float, a decimal value. If we say 9 slash 3, we get a rounded value. So that's what's meant by using the floored division. It rounds it so you don't have the decimal. Also, unary sign plus minus operators you can use for literals. Examples of ints and expressions, pretty standard math operations. Typical usage like math calculations, specifying programs, so this is, expressions that you should be familiar with, adding, subtraction, multiplication with using brackets, right? So I think the only one that's a bit different, is maybe multiplication. So we use star multiplication, so we get 3 times 5, get 15. Power of, we say 9 star 2, which gives 81, and then otherwise it's brackets and division. So I think that's all quite familiar, should be familiar to you. Integer operations. So we have, this code is also from the Python, from the Princeton course. So that one was called, int ops. That's the one. Int ops one. So let me just get that one. So we have it. Int ops, here it is. I'll share it as well. Let's add this file. Int ops.py. Paste the content. And again, if you want to know where it is, it's over here. All right. So get it, it's there. So we're importing standard IO and sys to get input value. So what does it do? It accepts in command line arguments A and B and use them to illustrate integer operators. What results in standard output. So we get two inputs from a terminal. We do addition, subtraction, multiplication, and find the quotient, or dividing by two, or dividing two numbers by each other. A quick note about Python 2 and 3. We don't use Python 2 much anymore. So in Python 3, the slash does true division, and slash does full division. It rounds it, so you don't have a decimal. So I use slash divide integers and slash to divide floats. All right, so also can work with the remainder with this modulus and find the exponential for A and B as well. So, and this is again straightforward commands to write out the values. So let's see what happens if we run it. Python int ops. And I need to input this value. So what examples do I do here? So 1, 2, 3, 4, and 5. Let's do that. 1, 2, 3, 4, and 5. There we go. We get the answers that we expect, and just illustrating the different operations that you can do. All right, so some comments here. This is command line arguments that we are using here. And then this converts into string. This line of code, string B, string A, converts your integers to strings. So this is the exercise. What does this one do? If I add 1, 1, and 3, let's check that one out. 1, 1, and 3. Okay, we get answers, which seem reasonable. All right, now we move on to floating point or real numbers. Floating point or real numbers. Floating point numbers. These are numbers, values of 3.14159, like pi, 2.0, and various other numbers, exponentials as well. Can do very similar things like integers, add, subtract, division. And these are the operators you can use as well. And just note here, there's no float value for pi or square root 2, one of the three. These are just approximations. So examples of float operations, these are, basic scientific calculations. The one thing that to take note of is maybe the exponentials. So yeah, that if I say, scientific notation, so 6.02 e to the power 23 over 2. I need to run Python first. So 6.02 e to the 23 over 2. I can make it a bit easier, like 1 e to the 2 e to the 10, something like that. Yeah, some scientific calculations that you can do. There's also this new library called math.square-root. So I think you have to import math for that. So this is a library for math operations. So we can square root a number using math square root 2.0 and get the answer or approximation for the answer. Also note your math.nan, this is a not number. All right, so modulus, what does modulus do? So here is another example just to try. So 2.0 mod 0.62, working at the modulus, 62 e to the 1, 3.8. And 3.8 is equal to those two, is actually equal to this expression, 10 minus 1 times 6 times 1 times 6.2. Excerpts from Python's math library. So we can find absolute value, maximum, minimum. This is a typo. Min works out the minimum. Interesting, there's actually a typo in the notes. the note itself, which I just should pick up for the math library. No, has actually been fixed on the has actually been fixed on the website. So maybe this is an old slide. So this should show minimum value of a and b. Sine, cos, tan, exponentials, all these inverse functions are also available too. I think these are just old slides. The website is updated and correct. Sine, cos, trig functions, random functions as well might be useful. And here is a quadratic equation to test out this. And this is also from the, this is also here. Let me get that as well. This is the quadratic example they have here. So let's try that out too. A new file is called it quadratic.py. Paste it here. Let's see, we'll go through this. Let's go through this example because I mentioned it. There's another float file as well that is in my video guide. I did walk through. They didn't mention it here in the notes, but you can do it if you can watch my walkthrough for the Princeton course. It covers everything in more detail. Here they didn't mention that file, so I cover all the content that is done on the Princeton online course for Python. All right, so what does this do? Import standard IO system math library, accepts floats B and C as a command arguments, computes the roots of polynomial x squared plus bx plus c. This is actually a typo. I mean, this effectively should be b times x. Bx would just give an error. So this is actually a typo in the website itself. You can't just type that out. Let's see, using the quadratic formula, write the roots to standard output. Okay, so we get b and c from the command line, work out the discriminant, find out the square root of it, and then work out your two roots. So let's try and run that. Let's set my active environment and say Python. Python quadratic. Hi. I actually spelled this incorrectly as well. Let me first correct that. Quadratic. Okay. And I got an error because I didn't give an input, so let me just put input for my 3.0 and 2.0. That should give me decent roots. Oh wait, I need to correct that. Roots of 2 and 0. Okay, so that's fine. Now it gets another one, -1 and -1 and -1. It should also work. And then this one gives us an error. We can't find the roots of that. There are ways later on we'll learn how to catch these examples, but yeah, this is a mastermind error. We can't find the roots of that, obviously. Okay, next we move on to Booleans. What is a Boolean? So Boolean data type represents truth values, either true or false from logic. So bool can be either true or false. It's stated here as true or false. This is how it's typed in Python. Operations and or not, aka ampersand, or an explanation. Truth table definitions. So this is useful to understand how truth tables work. If something is true or not based on conditions. It is a bit technical. You don't really need to know this in depth just to understand the basics of Python. So I won't actually go through this. The Python Princeton course does explain this a bit more. But again, it's not actually that necessary. I mean, it's useful to know about these truth tables. So again, we don't even cover this much in the rest of the notes. So it's useful to know for certain conditionals and loops. So we'll look at that a bit later on. So typical usage for control logic. This is where it's actually useful. The flow of a program using if and while statements, which was section 1.3. So what does the following program print to terminal when executed? So this is actually not in the notes, so let's try this out. I like trying out new files. So let's try and type it out. We're going to try type it out. And what's this going to be called? A bool file. I don't see. Yeah, there is no file there. Let's type it out. Let's create a file called bool test or bool operations dot bool ops py. Okay, let's type it out. Let's import sys, import standard IO, find function. Again, we haven't actually dealt with functions yet. So just copy as I'm typing, y is false, we define variables x and y. X is x and y, or not x or y. Okay, this is trying to trick you here. Y equals x and y, or x or y. And then standard IO. Standard IO dot write, convert that to string, and standard IO dot write, empty space, concatenate that with string y, and standard IO dot write line, empty space, concatenate with x or y. So they didn't actually cover this much in the notes, so this is their own explanation. And let's do our entry for this Python file, useful for modules, main, and then I prefer doing it in the line. All right, so let's see if we can run this. Let's do Python bool ops. Let's see what happens. Made a spelling mistake here. Once again, false, false, false. So that's what we get. And what answer is it? So what does the following program print to terminal when executed? False, false, false. So that's correct. So those are all the terms. So x and y. So we can work this out. So x is currently true, and x is true, and y is false. So if you and anything with false, you get false. Right? So this bracket is false. This is what you're getting here. If you or anything with anything with true, you're going to get true. So this one is true over here. If you're not the true, you're going to get false. So that's why it's false, false, and that's why x is false. And this follows the same method. That's why I get false, false. And if you or two falses, you're going to get false. So again, I don't see the benefit of going into much detail. This is logic operations, and we don't really use this to so much detail. You'll see there's similar examples we use a bit later on. So again, I'm not gonna go through this much. If you want, I can in the comments let me know. Comparisons. So comparisons, if you take two operands of one type, int for example, and produce a result of a type bool, low precedence than arithmetic operators, higher than Boolean operators. So let's do the examples, because it is quite useful, I think. Clear my terminal, just get Python again. So if you want to compare, is 2 equal to 2? That's obviously true. What about, is 2 actually 3? That's going to be false. 3 not equal to 2 should also be true, and 2 not equal to 2 is also false. And you have less than equal to symbols and whatnot. Examples that you can go through. How to check for beginning of a century. So this is a little example to work out the leap year, to work out of a century. Little exercise which we'll do shortly. But these are comparisons which you should be familiar with mathematical operations. Yeah, useful to work on non-negative discriminants and work out the modulus and legal month. So we'll go into more depth with these examples, how to use comparisons and a bit later on. A leap year. So this is from the Princeton course. So let me get that leap year example. So I don't have to type it out and take more time. So let's add it here. Leap year dot pi. Paste it, and here is the code for it. So is a given year a leap year? So this code tries to work out if a given year is a leap year. So accept an int year as a command line argument, write true to standard output if a year is leap year, otherwise write false. So how do you work that out? So this program tests whether an integer corresponds to leap year. Gregorian calendar, a year is a leap year if it is divisible by 4. If it's divisible by 4, like 2004, unless it is divisible by 100, in which case it is not a leap year, like 1900, unless it is divisible by 400, in which case it is 2000, for example. So that's how you work out if it is a leap year or not. It gives you the algorithm, so to speak, to work it out and use modulus to check the comparison if it's divisible by 4 or not. If by 100 or not, or yeah or not. So this is the code for that. So let's test it out, see if it works. Let's run that. So Python leap year. This first example was 2016. That's true. It's a leap year. 1900, not a leap year. And 2000 is a leap year. Yeah. If you want more details on this, it is self-explanatory, I think. Otherwise, leave a comment and I can give more in depth how this actually worked out. All right, so here they go into more depth. So let me do this as well. So, for example of a leap year. So we can actually do this in the Python environment. Okay, let's do 1900. Okay, let's just first do modulus. 4 modulus 4, what do you get? Get 0. How about 9 modulus 3? 0. How about 5 modulus 4? Wrong one. 5 modulus 4. All right, so this, I'm just giving you examples if it's divisible by the value that you are using the mod with. So for example, 1900 mod 4, this means that this leap year is divisible by 4, and there's no remainder. If I say, 1900, let's say 1900 mod 100, it is also divisible by 100, and in the same way 1900 divisible by 400. Is that correct? Divisible by 400. Yeah, so 300 has some remainder. So, and this is divisible by 100, in which case it's not 100, and this is divisible by 400, in which case it is 2000. So there it is. So that allows you to kind of work out the leap year and give you the operands afterwards of what to choose from. All right, so again, so modulus is just a remainder. This worked after division. So I had the example like we got the remainder here. So the remainder is 1. 4 goes into 5 once, and then there's remainder 1. Or if we say, for example, 10 mod 3, 3 goes into 10 3 times with a remainder of 1. So So how does leap years work? So if a leap year, again, just to clarify this, so a year is a leap year if it is divisible by 4, but not divisible by 100 unless divisible by 400. This is the algorithm that you got to try to work out. So, for example, the first line checks if this year is divisible by 4, but not divisible. We also have to check it's not also divisible by 100. And the last line explains or must be divisible or divisible by 400. These are conditions that we were given. So to explain this a different way, a leap year is a year divisible by 4, except centuries must also be divisible by 400. So that's another way to explain it. Yeah, hopefully that makes sense. And the examples that you have here to work it out. So there we got 2000. 2000 was one. Let's just work out these examples they gave us. Python, leap year, 2016. So this is a leap year. And then what about 1900? False, not a leap year, and 2000. That is a leap year as well. All right, library methods and API. So moving on, a library is an existing Python method module written by someone else, grouping by topic. An API is an application program interface. And we have used these quite a bit already. Not these ones just yet, apps max and min, but standard IO.write, standard IO.write line. And then other math functions. These are all libraries that we are using that allows us to do certain mathematical functionalities. Makes our life a lot easier. We don't have to write it out and work out how to work max and min for numbers. So arguments, these are inputs enclosed in parentheses and separated by commas following the function name. Python calls or evaluates this function with the given arguments, and the function then returns a value. So useful to understand how a pure function work and how to use these arguments inside a library. So these are various library functions. These are arguments inside the library functions. The one we are familiar with is hello, and math of square root is one we did as well, and returns a value. So these are built-in functions. So it's important to understand how these work, and we'll go into more in depth into various examples of this as well. All right, so this is the last section, which is type conversion. Let's see what it covers. So type conversion converts a value from one data type to another data type. So automatic and implicit, no loss of precision, promotion, or with strings. Explicit, cast, or method, casting, higher precedence, and arithmetic. Okay, so different types of type conversion. So the first is casting. So for example, you have string conversion 2.718 converts this value integer 2.718 and 2 times 2. For int 2.718, you're losing information. You're losing 2.718 because it's not converted to integer. Say for 3.14159. For float, decimals added, and also for rounding as well. So this is difference between explicit and implicit. You have promotion, where you where there's no loss of precision or promotion. This is one of the methods that we're using to square root. In terms of strings, we have precedence. In terms of expressions here, this one note here is about precedence. Everything in the in the round brackets precedes the division. So something useful to take note of, and this follows like the BODMAS rule. So random integers, given n, generate pseudo-random number between 0 and n minus 1. Why not n? Well, let us see what output we get. So this is another example from the course from Princeton. This is a random number example that we can take and get, which is random. What's the file called here? A random int. As random int. Did this in my previous walkthrough. Random int. I think it's in the other program here. If not, let's write it ourselves. Oh, here we go. Create a new file called random int.py. Looked familiar, but not sure why I can't find it now. So import sys, import standard IO, import random. Find of main function, n equals int sys.arg v, expecting input from terminal, random creates a random number, and then t equals int r times n, float to int, so multiplies a random number with some value n, and we just write it out to terminal standard IO. Right line t into float, which is implicit, and then we write an entry point if name equals name. Okay, let's see what the code does. Let's run it. Python random int and make it 6. So what this does is it takes an input value, 6, what we got, creates some random value, I don't know what it is. And then here it multiplies the random value. Let's make it like, for example, let's say it's like 50 times, I don't know what, 50 times 6, for example, and then writes it off with this. So in this case, answer was 5. So it could have been some decimal that is writing out. In actual fact, let us improve this a little bit. Let us see what this random value actually is. This actually makes our lives a lot easier. So let's make it 6. So the random value was 0.506 times 6 gives you 3. Right? So that actually helps us to add that as well. So other examples of like 1,000, 10,000, random number as well. So why not n? N minus 1. As far as I know, n is not included in creating the random value. You'll see this with lists as well, or ranges. The final value is never included, is always n minus 1. But we'll see more examples of that. So summary, what have we done so far? We've done a data type is a set of values and a set of operations on those values, both both in data types. We looked at strings for computing with sequence of characters for input output, ints for computing with integers for math calculations and programs, and floats for computing with floating point numbers, typically for science and math apps. Bool for computing true and false for decision making in programs. Python, you must declare and assign the values to variables. Convert from one type to another is necessary or when necessary. Pay attention to the type of the data, even though it's dynamically typed. Dynamically typed language. Python also has an interactive mode, which we've been using, resource calculator, and this has a hop function as well. So it can also say, I think it should work here. Yeah, hop function as well. All right, that's the end for the first lesson. Stay tuned for the next one.